All right, this lesson is going to go over lesson 911, which is an introduction to inequalities. Please make sure you are taking notes while you watch this video. All right, so first thing, definition of an inequality, which you should have learned in the past, is a mathematical expression that compares two expressions. Okay, so basically it's a comparing symbol. I should have wrote a mathematical symbol that compares two expressions. So first thing, you can see this one, it's comparing x and 2, and it's saying that x is bigger than or equal to 2. You guys should know that symbol. This one says that x is less than 3. So you could come up with some solutions to this. So if I asked you what are some numbers that make this true that you could put in here, well, I would say 3 works because 3 is bigger than or equal to 2. 4 works, 5 works. Does 2 work? Yeah, 2 works. There's a lot of numbers that work. Okay, basically anything bigger than 2. Okay, same thing here. You can fill in numbers that would make that true. 0 is less than 3. That works. 2 is less than 3. 2.9 is less than 3. Okay, there's a ton of numbers that work, but that's the definition of an inequality. All right, so what's the difference between equations and inequalities? Okay, well, equations, in most cases, they have one solution, like x equals 2 or x equals 5. Okay, so in most cases, they have one solution. Sometimes they might have infinite solutions. Sometimes there might be no solution. Okay, but in most cases, there's one solution. Inequalities, one like this, there are multiple solutions, okay? So this inequality has a solution set of any number that's bigger than or equal to 2. So like 2 works, 3 works, 4 works, 5 works. All right, so there's a lot more solutions to inequalities. All right, how many solutions do they have? If you look at this one, it says x is less than or equal to 1. Well, I could list tons of numbers. 0, -1, -2, -3. There's a ton that work. There's actually infinite solutions to an inequality like that. Okay, if I looked at this one, how many solutions are there to this one? Okay, think about that for a sec. All right, this is a betweener one. So it says x has to be between -1 and 4. So I can think like 0 is between there, 1 is between there, 2 is between there, 3 is between there, 4, and then there's lots of decimals. So there's still infinite solutions, but there's only a set number of those, okay? They have to be between -1 and 4. All right, so inequalities are kind of special and have some of those characteristics. Okay, I'm going to try to write an inequality that represents the solution for each of these number lines. So let's look at this first one. You can kind of see it. They kind of made it a little bit darker, but here's the answer to an inequality. They're showing it like this. Like 2 works, 3 works, 4 works, 1 works. Basically, it's all the numbers bigger than 1. So to write that, I'm going to say x, because that's all the numbers, bigger than 1, and it also can be equal to 1 because that is shaded in. So there is my inequality. Okay, for letter B. Okay, you can see it starts at 1. That's something called the boundary point, by the way. And it's all the numbers smaller than 1. So I'm going to start with my x. That's all the numbers smaller than 1. Could it be equal to 1? Well, if you guys notice right here, that circle is not filled in. That means it doesn't include 1. So there's my inequality. Okay, I want you to push pause and try these next two. Okay, so the next one, I see it's all the numbers smaller than 3. So I'll write x has to be smaller than 3, and it can be equal to 3 because that dot is shaded in. So there's my inequality. All the numbers less than or equal to 3. Okay, now letter D. I hope you guys notice this is a between one. It's between -4 and 2. So if it's a between one, I always put the smaller number, -4, and then 2. X is between there, okay? Now, it's all the numbers bigger than -4, right? So I'm going to say x is bigger than -4. It does not include -4, okay? And then comparing to the 2, it's all the numbers smaller than 2. So I'm going to say x is smaller than 2, but it could be equal to 2 because that's filled in, that dot's filled in. So here's my inequality for that one. All right, so I want you to go ahead and write this inequality down, and I want you to push pause and find at least 5 values that would make this inequality true. All right, so you should have found some numbers. I could have said 10. If I did this, 2 times 10, that's 20. Take away 5 is 15. That is bigger than 3. Okay, so I know 10 works. I'm sure you came up with some more. I could do 5. 2 times 5 is 10, minus 5 is 5. That's bigger than 3, so that works. Now, there's a lot of numbers that work. There's actually an infinite number of solutions. Okay, but what if I wanted to figure out how could I list like every single number that worked for this instead of writing it like that? All right, so what you do to figure that out is you need to try to find the smallest number that works for x, the very smallest one that would actually work. All right, so I could maybe think, well, I know 5 was a number. Maybe let's try 3. 2 times 3 is 6, minus 5, that's 1. That doesn't work. Let's try 4. 2 times 4 would be 8, minus 5 is 3. Okay, 3 works because it says it can be equal to 3. So 4 was the smallest number that worked. All right, that point is called a boundary point. Okay, now that point is special because that helps me say, well, what are all the other numbers that work? Well, I know it's every number, we just said bigger than 3, or not 3, sorry, bigger than 4, okay, or it can be equal to 4. All right, so that's called a boundary point. And again, that's special because that kind of tells us that's where the numbers start, and then I either go up or down from there. Okay, now, here's how you actually solve one of these. I'm going to kind of show you. So if you write this down, 2x minus 5 is bigger than or equal to 3. Basically, you're going to solve this just like an equation. Kind of just ignore this symbol. So I'm going to add 5 to both sides. Just like an equation, I get 2x, and on this side I get 8. Okay, divide by 2, so I get x is 4. There's your boundary point. That's the smallest number, or that's kind of the special number that'll make it work. Okay, so to show that 4 is the special number, I'm going to draw a number line. Okay, I'll just put 0 in the middle, 1, 2, 3, 4, 5, and then -1, -2. Okay, so 4 is my special point, the boundary point. So I'm going to come over here, put a dot here. Now, I see that my symbol was bigger than or equal to, so I can shade that in. Now, I want to know, is it the numbers bigger than 4 or smaller than 4 that worked? Well, when I was listing the numbers, they were all bigger than 4. So I'm going to draw my arrow going this way. So every single number bigger than 4 is my solution. So here's how you would write an inequality to show it, and then here's how you would graph it down here. Shows all the numbers bigger than 4. Okay, so let's try another one. So again, very first thing you want to do is find the boundary point. So solve it just like an equation. I'm going to end up subtracting 3 from both sides. Okay, that cancels. I get -2x, and then I'm just going to put an equal sign. Just pretend it's an equal sign, and then -2. Okay, next thing I'm going to divide by -2, and I get x equals 1. So that's my boundary point. Okay, so I'm going to go ahead, draw my number line. I'll put 0 here, 1, 2, 3. I'll put some negatives. Okay, my boundary point's 1. All right, now I need to figure out, does 1 actually work in the original problem? So if I go back to the original problem that I had, if I plug a 1 in there, it says 3 minus 2, 1 is 1 less than 1. No, that does not work, so I don't shade it in. Okay, now I need to see, well, do the numbers bigger than 1 work or smaller than 1? And to do that, all you need to do is pick a test point. Okay, so to pick a test point, you can either pick any numbers bigger than 1 or smaller than 1 and just plug it in and test it. I'll choose the numbers smaller than 1. So let's say I'll choose 0 for my test point. Okay, I'm going to plug 0 in here. So 3 minus 2 times 0 is 0, is less than 1. 3 minus 0 is 3 less than 1? No, that's not right. So 0 and the smaller numbers don't work, so it has to be all the numbers bigger than 1 work in this. Okay, so if I was going to draw this, it's every number bigger than 1. So now my solution, I got to write it, is it's every number bigger than 1, but it doesn't include 1. All right, let's try one more. So again, to solve it just like an equation. We need to find the boundary point. So I'm going to subtract 1 from both sides. I get 3x, and then I'll just put equals 6. Okay, I'll divide by 3. I get x equals 2. So 2 is my special point, or my boundary point. So on my number line, I'll put 0, 1, 2, 3, -1, -2. Okay, on my number line, I'll come put a dot by the 2. Okay, now I need to see, and first thing I might even notice is it doesn't say it can be equal to, so it's not going to be shaded in. So now I need to test a point. Is it all the numbers bigger than 2, or is it the numbers smaller than 2 that work? Okay, so I'll go back to my original problem right here, and I can pick, let's say I try 3 as my test point this time. So let's plug it in. 3 times 3 plus 1 is less than 7. Let's see, 3 times 3 is 9, plus 1 is 10. 10 is not less than 7. Okay, so this does not work, so it's not the numbers over here, so it has to be the number smaller than 2. And if you weren't sure, pick another test point to try. Pick 0. I'll plug 0 in. That's pretty easy. 3 times 0 is 0, plus 1 is 1. Is 1 less than 7? Yeah, so I know it's all the numbers less than 2 that work. So that's how you solve inequalities and how you write inequalities. So we'll kind of learn more about this the next few days in class as well.